Hey guys, it's Ken here from Shop3D.ca, and today I have with me Felix, our Senior Application Specialist.
Hi everyone.
We're going to be doing a virtual presentation for you for Flip the Normal. And we have all this cool stuff here. Felix, what are we doing today?
Yeah, today we have a project plan for you guys. So we're going to be reverse engineering this graphics card bracket. So we already have one, and we actually have another graphics card, but obviously has this broken piece out of it. So we're going to be using the Einscan HX here to 3D scan it, then reverse engineer it, and then 3D print it in a bunch of different technologies so that you can see what that looks like.
Now it's important to know why we have all of this awesome gear, and that's because at Shop3D.ca, this is what we specialize in: 3D scanning, 3D printing, and 3D design. And we have showrooms in Toronto and Vancouver covering the East and West Coast. So, what should we do?
Let's get started.
Okay, so we have our setup ready and we have our problem in place. So we have a graphics card where we've got some damage.
Yep.
Felix, what do we do? Because Bitcoin mining is very important to our organization.
It's very important. Well, traditionally, you know, if you had a broken part like this, you'd have to go on Kijiji maybe and buy a different part, like a dead graphics card or something, so you can salvage this part out of it. Or you go in, if you're a good designer, you'll measure every single thing here and then basically redesign this whole
But
thing.
that's pretty complex to redesign.
This
That's
is
gonna take hours and hours.
This is pretty complex, especially if you want it to look like this one or better, right? So you can design like a blocky looking thing, but that's not really gonna cut it if you want your desktop to look nice. So what we're gonna do, we're gonna scan this entire thing using the HX. We're gonna need your help to put some dots on it, and maybe we'll even use the spray. We'll see how it picks up. And then from there, we'll use the Solid Edge software, which is just a regular CAD software that comes with a scanner, where we're going to be just kind of touching up specific areas like the holes and the mounting screws and specifically those parts. And maybe if we have some time, we'll put some cool designs on it.
So we can even improve on our design and airflow.
Yeah, we can improve on our design. I don't know if we can improve on our airflow without a little bit more effort, but yeah, we can make it a little bit cooler looking for sure. For sure.
Sounds good. So what's the first step for us?
So the first step is obviously we're gonna have to scan it. Now, if you're taking the scanner out of the box, let's say you just bought it, we're gonna need to calibrate it. So let's get this out of the way, and Ken, why don't you go ahead and pull out the calibration board.
Very, very nice box here, and this is what the HX comes with, and this is the calibration card.
Yep, so this is the calibration board. So you have a white balance calibration on the outside, and on the inside you have this funky looking pattern, pointed right there. So we're gonna have to do the calibration. Really, you only need to do this once, just if you're only working in this specific room forever and the lighting doesn't really change much, really you just have to do this once and then forget about it for a while. But if you're transferring this entire thing to different locations and different environments, you'll wanna calibrate it before every time you start. All right, so we're gonna do that right now. Ours is actually not calibrated to this specific computer. You will have to do it for every computer you use, but normally people just have one.
So since you're doing all of the scanning and work today, I will be your assistant.
You will be. So my assistant, please put some dots on it, and you can find some in the box actually. But yeah, put them on there. And the reason we're putting the markers on, not because it really needs it, but because we're gonna be using the laser scanning mode alongside the other mode, which is the LED scanning mode, just so we can show off the entire thing. So while you're doing that, I'm gonna calibrate the scanner.
And these markers are really just tiny little stickers that come with it. The scanner knows to look for them.
Yep.
And the more random I place, the better it is, right?
Yeah, so you want it to be very random. You don't want to have any type of pattern, just so that the scanner has a little bit of an easier time.
And Felix, how much markers should I put on an object that's not that big?
Not too many. I think of maybe actually a little bit more than that is going to be okay. So maybe put in like 6 more on that side. Okay. And realistically, you want like a cluster of like 3 dots per, I'd say like maybe like a 2-inch area.
And because we are scanning the entire object, I should put it on all sides of that.
Yes. The way we're actually going to be scanning it is we're going to be standing it up on this side. Okay. Or maybe, yeah, on this side, we're going to figure something out there. And then we're going to go around with the scanner. All right, so right now I'm doing the calibration, and hopefully you can kind of see what I'm doing over there. So it's very easy. You just kind of follow whatever it says on the screen over there. So it is asking us to scan it in 5 different positions.
So Felix, why are we using this scanner in particular and not this guy here, which is a different color?
Yeah, so you have the HX here, sort of the top of the line one, and then the Einscan H is very similar, but it's made a little bit more for scanning body parts and furniture. So I think that scanner, and we've used it and it's very good. So scanning faces and you know, just entire humans in both with the texture or without the texture is really good. And then scanning furniture as well. I think that that one is a little bit more for maybe VR and AR, and maybe even for game development and stuff like that if you wanted some really real looking objects in there. But that would be the main difference, and the HX is designed a little bit more, well, solely for reverse engineering, just because it has a way better accuracy and scanning mode. So right now, before I did just the LED calibration, right now we're gonna do the lasers.
So in terms of this scanner here, it's a combination of laser and LED light?
Yes, correct. So we got the blue laser here, and we have the blue LED light. And maybe you're familiar with white LED light scanners. The blue LED light is going to be a little bit better, just because it's a bit of a tighter wavelength in terms of the light, which means that, you know, all the white light that we get from the regular lights in the room is not going to be affecting your scan. So that's good. And I think we have one more mode. Yeah, we have white balance as well. And we are good. So now we're actually ready to scan, so we can put that board away. And it's actually important that we don't scratch this up, so be gentle with it. Now you did put a few dots on there, and that will help us, especially because it's a flatter part, so going around it's going to be a little bit harder without the markers. So that will help, but I think we're still going to have to spray it because it is pretty black looking.
Okay.
So let's do that, and we have a couple sprays, right?
Yep. So we got the blue and the white.
Yes.
The blue and the white.
So one of them actually, so both of these sprays, what they will do is they will coat the part in this sort of chalky texture basically, and that will pick up, the scanner will be able to pick it up a lot better. But one of them actually disappears, right?
Yep.
And it takes about 4 hours for it to disappear, and that one is best for things where you don't really want to take it to and wipe it down with like water or anything like that, or even electronics. I've scanned a tablet with it, and it works really good. So today we're going to be just using the regular one, just to give ourselves a little bit more time to scan the object.
So do I just evenly coat it?
Yep. So let's. We're just going to do an even coat, and then we're going to wipe away the spray from the markers. Now, if you do it the other way around, so you don't have to wipe it, the markers don't actually stick to the chalky spray. Right. So that's why we have to do it this way. So go ahead and do that.
Okay.
Okay, I think that's good. We'll let it dry a little bit, and as it dries, we'll just clean up these dots.
So we put our markers on it, we've sprayed it, we've cleaned it off, and we're ready to scan. I see that there's 2 modes available.
Yes.
Looks like rapid and laser. What are the differences and which one will we choose?
So we're going to choose laser, just because we have the markers on it, and I think for this flat shape it's going to be a little bit better. And then for rapid scan, we're actually, in rapid scan rather, you're using the blue LED light, which I don't think is going to turn out that well here because the shape is pretty flat. Okay. I'd say that one is for something that is a little bit less flat and more feature rich is going to be the best way to do that. So we're going to go with laser for this one.
So is it safe to say in general, laser scan for more difficult objects and then rapid scan for objects with a lot of texture that you can recognize, that the scanner will recognize?
I wouldn't categorize it exactly as that. I think with experience, the user does get kind of familiar with what laser scan can do and what rapid scan can do. So I'd say it depends on the application.
Okay. And in terms of the output from those 2 scans, will the laser scan give you more data?
Not necessarily more, but I think that more accurate data usually is what you get out of it.
Okay, good to know.
But it's not crazy different, I would say. Yeah. So the specs say one thing, but I'd say that at the end of the day, it's not crazy different.
Okay.
All right, so we have the project ready to scan. So we have the markers on there. So all we have to do now is just press the play button here, and that will give us a preview so we can take a look. And then we can use these buttons here, the brightness buttons, to adjust if we need to. The arrow keys are actually to zoom in and out on the computer. So they don't really do much, but it's there for you if you need it. So we're gonna click once for preview. and you'll see a bunch of dots and a bunch of lines. And click again to start scanning. So here you are. So you're going and making sure that you're covering the entire area. So we can go a little bit this way.
It's interesting to see how once the laser line passes, you get all that telemetry up here on the screen.
Yeah, it's a really good preview of what's going on. So I'm gonna hop over to the other side. And the nice thing about the scanner is that you can pause and then, reposition and then continue scanning. So one more time for preview, just to make sure you're hitting the right spots. And there's actually a bar over there on the left that will tell you if you're too close or too far away, which is useful. And I believe that if you have the sound of the computer on, it will actually audibly tell you if you're too far or too close.
And it looks like you're going pretty slow with a steady pace. That's kind of the method in which to scan it all around?
Yeah, that's kind of the method. And I think for flat pieces like this, I tend to go a little bit slower just so I don't lose any of the positioning as I go around. I'd say this shape is actually pretty difficult to scan overall with any scanner. But actually this is doing a pretty good job right now.
Yeah.
So you can see all the markers are being detected, and we're going very slow to not lose positioning over the flat piece. And there you go, we kind of stopped there, so we'll need to pick up a little bit more data. And we're good.
Yep, so that looks like it took us about maybe like a couple minutes.
Yeah, a couple minutes.
To get through the whole process.
I'd say, the setup was actually a little bit longer. Maybe it took us 5 minutes or so. So overall, start to finish, if you know what you're doing and you've been using the scanner a little bit, then, maximum maybe like 15 minutes on this part.
So let me ask you, if you were to model this though, as accurately as this, how long do you think that'll take you?
That will take you more than 15 minutes for sure. I think that with a scan, you will have a way easier time because we don't actually have to model all of it.
Right.
We just have to model specific parts that we need to change, and then we can keep the rest. Right. So the organic shapes or the curvature on the outside here, we're not going to touch. We're just going to reconstruct, or rather even just copy and paste this. So once we've reconstructed this area, we're going to copy it over to this side, and we can use these holes to position that. And all that is done in Solid Edge, and it makes it pretty easy to do.
Awesome.
It shouldn't take too long. Yeah.
Great. Okay, so should we get started on the next portion?
Yeah, so let's get started. So I'll boot up the Solid Edge software and we can get started.
Okay, we're back, Felix, and we've got some new pieces here. Let's talk about what we did to get to this point.
For sure. So after we finished our scan, I took it over to the computer and did some reverse engineering on it. Mainly what I focused on was just the brackets and the hole sizes here. And then I added a little bit of funky patterns here. And also I named each one of these parts with a different name because they came off of different machines.
Yeah, I see that it's been customized versus what it was originally, but I do see some obvious quality differences here. Can you take me through the different processes? And I guess the customization was we put what process we used on it.
Yes.
But let's start with the FFF version.
Yeah, so FFF version I would say looks pretty rough compared to the other ones. But what's nice about this one is that if I would have done things a little bit differently, I would have actually printed one of these, compared it to the card, make sure that everything fits properly, do some adjustments on the computer before I would have moved on to something that looks a little bit nicer like SLA and SLI.
Yeah, and we have some rough parts around some of the edges, and I think that's partially due to us having a time limit on the scanning portion of it, we really wanted to do a scan that was representative of a real-time scan, even though we could spend a lot more time doing that and we would actually get a better result. So, okay, so let me talk to you about this in terms of the printing aspect of this, not just the scanning. How difficult was it to print this piece, and how did you print it on an FFF printer?
Yeah, so we actually used the Ultimate KRS-5 for this, and we used dual extrusion. So the black part you see here is just, I think it's Tough PLA. I went with Tough PLA here. And then the underside, you can see that it's still rough here, but realistically you're not seeing this on the actual object. But we actually use soluble supports so that we can, all this weird geometry would come out well and easy. We didn't want to be reaching in there and removing supports and potentially breaking parts. So that was that's kind of nice over here on the FFF side.
Yeah, and if someone does not have like an S5 with dual extrusion, how difficult would it be to print this piece?
I would say not super difficult, but they'll have to be careful with removing supports.
Right, so that would just take more time in terms of post-processing to get to this point.
And you might break it. But,
and you might break it, yeah. So in terms of this piece, would you say that this is a functional piece if we were to put it in with the card?
Yeah, I'd say these are all functional pieces. Maybe I would have used a different material, something a little bit more heat resistant, like ABS, maybe PETG. But overall, if I just wanted to use this, I just needed the card to work. Yeah, any of these pieces would work. I'd say this just looks a little bit rough if you ever look inside the computer.
Right, but the upside of this is probably cost us the least to print.
Definitely.
Right.
Yeah,
and what about in terms of time between, let's say, all of these versions? What would take the longest to print with?
I would say between all of these, FFF and SLA is about the same time, around 12, 14 hours to print with soluble supports and everything. SLS actually took the longest because the way that I had to fit it was sort of on an angle inside the build chamber. So you might know with SLS, the taller your chambers are, the more time you have to spend. So this took, alongside a bunch of other parts, this took more than a day. Between printing and cooling.
Okay, it seems like a different process with a little bit different qualifications needed to print it. So I'll get into that a little bit later. Let's talk about the middle one, the SLA part. I see smoother surface quality. What else should I know about the SLA compared to the FFF print?
I'd say the SLA looks great on this side, but you flip it over and you see a whole bunch of little marks. Now these are support marks, and for those that are familiar with SLA, you will know all about this. And now sanding these down is not going to be crazy hard, and you can do that fairly easily with some 2000 grit sandpaper. But overall, this part is also acceptable. I would say we would spend a little bit more time making sure it's all clean so this shininess goes away. And then we actually didn't post-cure this part as well. So that's something we have to do still. But overall, either this one or this one, depending on what you like, would work.
I also see that in terms of differences, that some of the finer features on the SLA print seem to be better pronounced, like some of the holes seem to be rounder and more defined. And I think that just speaks to the SLA quality in terms of precision. So let's talk about the prettiest piece here, the SLS print, and this was done on the
Fuse One.
Fuse One, okay. So yeah, tell me about that. You've already fitted it in, so obviously tolerances are good there. Tell me more about how you printed it and what was the result compared to these guys? Yeah,
so like you said, it looks the best. So out of all these ones, I chose to put that one on as sort of our final product. Now everything works here. All the fans spin. Everything looks good. The tolerance was great. In terms of actually getting this part out of the machine, once it's out of the machine, the Fuse One is a whole bunch of powder in there. We take it to the sift, we remove some of that powder, and we actually also have to take it to the bead blaster. And that's what gives it this sort of matte and powdery finish that you see here. That actually works really nicely with the card.
Yeah, it does. It almost looks like a finished piece with bead blasting, finished as a purposeful finish for it. And I would say that, if you were to replace the damaged card, that would be more than perfectly acceptable.
Yeah.
Custom modified, and it's fairly robust as well, right? What material is it?
Yeah, so that's nylon 12, so that's going to be, that's going to be pretty good.
Okay, so if I bump it around while putting it into my computer,
yeah,
it's not going to be a problem.
No, not going to be a problem at all. And it has about 80 degrees heat resistance, so you can throw whatever you want at it, basically.
Let's talk a little bit about best practices. What can we do to both optimize our scanning and optimize our printing, and choosing the right technology to print it, so that we would get better results right from the get-go, learning from the lessons that we have in doing this in this experiment?
For sure. I mean, for scanning side, I would say just go slower, spend a little bit more time, put a little bit more markers on there, and overall make sure that that spray that we applied is a little bit more even.
Okay.
So there's no like big bulges or anything like that. And then on the post-processing side, spend some time there, make sure that faces are flat, that your scan is as good as you want it to be,
Right.
and then move on to reverse engineering and adding these brackets and whatever else you want to add. Yeah.
Right. So just like in a lot of things, the quality of your source,
Yeah.
results in what you get after you've printed it. So let's talk about the different technologies now. Obviously, the Fuse one, looks, feels, and is probably the most appropriate for this application. Where would that change? Where FFF might be more appropriate, or SLA might be more appropriate? Like, what circumstances, if we're not doing a graphics card enclosure, would we choose some of the other technologies?
Yeah, I mean, anything functional, you kind of want to go with FFF.
Okay.
You can get any material you want, carbon fiber, nylon, polypropylene, glass fiber, polypropylene. So if your application was a little bit more about, on the production floor, you wanted to introduce some tooling aids or anything like that, FFF would be a great way to do it. Moving on to SLA, if you're scanning sort of this art piece or something you want to put on display, SLA would be the way to go. Yeah.
And I know that there's a lot of different types of materials for SLA as well. Like there's a high temperature material.
Yeah.
We could do it in that for this as well. If we knew it hits 100 degrees, for example, then we can use high temperature resin. And that one would be pretty unique as well, actually,
it
because
would
it would be clear.
Yeah.
That'd be a pretty good look for it. And I don't think these guys could do clear like SLA can.
Yeah, I mean, you got some translucent stuff for FFF, but nothing like SLA.
Right.
Yeah.
Okay. And so this application obviously is the best for the Fuse, but is the Fuse going to be the best in every single situation?
No, I would say even for this application, I mean, if you're just printing one of these and that's all you're putting in the build chamber, you're gonna be spending a little bit of powder there.
Okay.
So if you are running a batch production of this, then it would make sense. Or if you're contacting a service bureau, then it would make sense to go with something like SLS.
Right.
But just like this one part inside that chamber, probably not too much.
Right. So
but
there's
yeah.
always that cost aspect to take
Yeah.
in consideration, as well as the quality and the functionality of it. If you were to have one technology, what would you rather have on hand all the time?
So I'm spoiled, so I have all of them. But if I just have one, I would say FFF is the way to go.
Okay.
It's the easiest to use. It's the most straightforward, and also the most affordable in terms of how much film it costs and how much time you're putting into it as well.
Right, and it'll be easiest one to start with.
Yeah.
So you can always get this and expand your line to more technologies.
Yeah, and that's what we see most people do, right? They started with FFF and SLA, and then they decide that there's room for both, and then later on, if they become big enough or they have the right application, they'll move on to something like SLS.
Do you have an idea for me, what it costs to print all of these items, just in comparison, as a rough number for people to know what a per part cost would be?
Yeah, so in terms of material costs, you're probably looking between like, I don't know, $3 to $10 on this.
Wow.
Maybe a little bit more because of the soluble supports. This will be a little bit more, I would say around the $30 range,
Okay.
just in raw material cost. The SLS one is a little bit more tricky because if you just printed this part by itself, the cost is going to run quite high.
Right.
But because we packed this build chamber up, 30% plus packing efficiency, it didn't really come to a lot. So if you kind of weigh this part, you're looking around, I don't know, like 50 grams, 100 grams or something like that. And then comparing that to how much a kilo costs, which is around $80, $100. So, not too much, but it really depends how you pack your build chamber. So
Right.
that's a little bit more specific if you wanted an ROI on it.
Right, because for these technologies, whatever you use is what your print costs, but for this, there's consideration
Yeah.
in terms of efficiency of printing.
Yep.
Great. Well, I think that's a great overview
Yeah.
of an actual project that we had, and something that we were able to complete fairly quickly and with minimal tools, really. So what is our takeaway from this project, Felix?
Our takeaway? Well, you can do whatever you want with a scanner or a 3D printing technology, but at the end of the day, it comes to does it make sense for your application, right? So this was a great demonstration, in my opinion. We scanned a really pretty difficult object to scan,
Yeah.
generally. Flat things and things like this are going to be hard to scan, no matter what scanner you use. So this was a great demonstration of what the scanner can do, and then we have a whole bunch of different technologies. So if you've never seen 3D printing before, this kind of gives you a really high-level view of what they all might look like and what you might use each one of them for. All right, Ken, so we talked a lot about scanning. We talked about the different technologies that we use and a little bit about the service of Shop 3D, but maybe you can expand on that a bit.
Yeah, for sure. So we're actually here in our Mississauga showroom. Around us, we have a whole bunch of 3D printers and different materials for you to look at, so it's definitely worth the visit. We also have a Vancouver showroom as well, which is a slightly smaller version of what we have here.
But I think it looks nicer there.
It does look nicer there. That's our flagship showroom over in Vancouver. But aside from just seeing all of the 3D printers, prints, and so forth, I think what really makes Shops 3D special is what you do, which is finding the right application, tools for the application for those out there. So can you tell me a little bit about that?
Yeah, so my job here is to help people like you and companies like yours to realize some sort of solution to a problem that you have, right? So if it's 3D scanning, reverse engineering, 3D printing, whatever it is, maybe you already have 3D printers, you're looking for new materials. We have over almost 6 years of experience in this industry and a little bit beyond. And between all of us, there's a decade or more, I think, at this point. So yeah, that's my job here, to help people like you and realize some sort of solution for your problems.
Absolutely, and I'm sure you can tell, but we are still absolutely thrilled at all of the new technology that comes out year after year, whether it's new materials coming out that's easier to dissolve, or new systems like the SLS Fuse system from Formlabs. We're still absolutely excited about this, and we always like to talk to people who are excited about this technology as well.
So yeah, if you want to hear more, you can book an appointment with us, or really just walk into any of our showrooms, and we'll help you out, have a chat about what you want to do.
And we also have a YouTube channel as well with a ton of resources available for you that goes more into detail of all of these different technologies. So make sure you go to our YouTube channel and subscribe there as well.
All right, so I think that wraps it up. So thank you for tuning in. My name is Felix.
And I'm Ken.
Till next time.
Bye.